Hello everybody and welcome. My name is Samir Aoudi and this is CSF3203 revision part 2. A disclaimer for my subscribers: this is specific to my college course called Intrusion Detection and Ethical Hacking. And number 2, this is a revision, meaning I'm gonna be really rushing through a lot of concepts and focusing on the most important ones. We have a lot to cover, so let us get started. So we will start with the malware chapter today, and if you remember, this chapter covers a full learning outcome in the course, CL03, so therefore it's very important. Let's start with the word malware. It comes from two words: malicious, meaning something with bad intentions, and software. Together they are malware, and malware is kind of a big category. Under it we find a lot of things, including the very known keywords like viruses and worms, and the more recently added types like ransomware, for example. So malware, they differ really, and they can be classified in many different ways. And the intention itself of the malware can be something simple. So you just want to show off that you created a malware that gives you an alert or some kind of a message. And of course, it can go all the way to holding your computer and your computer files hostage until you pay a ransom. So the goals of the hackers always differ. When we talk about malware, it's considered a type of attack. So somebody creates a file, a malware file, and distributes it somehow, and it reaches our computer doing something bad. So it is an attack, and we can specify two types of attack: an attack on a standalone computer, and this is called a computer attack, and an attack on an entire network, including the network infrastructure, the network services, and of course this is called network attack. So we do attack network through computers, right? So don't really confuse this. It's just that when we say computer attack, we do mean a standalone computer. So if you're at home and your computer is infected, that's it, it's your computer. But if you're in the college, you're part of the college network, when your computer is infected, it may affect something else in the network, depending what kind of controls are present. We all know the answer to this. What are the sources of malware infections? And still we do things we shouldn't do. We click on links, whether it's on emails, whether it's on websites. We go places we shouldn't. We download, we open, etc. And one way malware is distributed is through tricking us. So the link itself, it would be something flashy, something maybe warning you, something scary, do this, or something will happen. And of course, a lot of people fall victim for these kind of social engineering approaches, if you will. So let us start with the most common type of malware, and it's a keyword or a term that's been used really for almost any kind of malware. Just people say virus all the time. We can compare or contrast a virus to a worm in the sense that they're both malware, but they differ in their behavior and in the way that they infect our computers. So we can kind of compare them to the virus, an actual biological virus, and a worm, an actual living thing. So we start that they're both types of malware. A virus needs a host, okay? Like the coronavirus, for example, it needs us human beings as a host, and a computer virus needs some kind of a file. So as opposed to that, the worm does not. So it can be something on its own. Again, like a worm, it's a living thing that can move on its own. Talking about moving, a virus needs a host to replicate. That means to go from one place to another. It needs a human interaction, us clicking something, opening something. While a worm, on the other hand, no, it can spread itself without us doing anything. Trojans are also very known and very special types of malware because they kind of look harmless. Okay, so the word Trojan comes from the famous Trojan horse, which is something that we learned about in Troy, the city of Troy, that was under attack. The enemy couldn't infiltrate the city walls, so at the end they kind of sent something that looks like this picture right here, a big wooden horse as a gift. Inside it there were a couple of warriors, and as soon as the gift entered within the city walls and everybody was partying, these warriors climbed down and opened the gate, and it was game over for Troy. So here, what's the similarity is the fact that the Trojan horse malware comes to our computers as harmless and useful kind of an application. It can be a game, it can be just any utility app, for example, but within it there is something else, something malicious. And this can be, again, a virus, a worm, it doesn't matter. It's just the fact that we're wrapping it with something useful using a wrapper. For instance, a wrapper is a special tool that allows us to bind or wrap these two entities together, and then we have a malware. Now, the type of malware that a Trojan is really differs. You can do pretty much anything you want to do, so it can be a simple virus. But let's think about it for a second. If you're gonna, put the effort to create a Trojan, you're not gonna just create a simple virus and put it and wrap it and spread it. No, you wanna do something more sinister. You wanna do something stealthy. You don't wanna get caught. You wanna leave some kind of a backdoor. You wanna control a computer, the victim computer. So it's very common to see what we call remote access Trojans, or RAT. And I created a video how to create a RAT. You can refer to that. So somebody actually asked me in the comments of that video about, what's the best way to detect the Trojans. And, I think he talked about some like writing a script or some techniques. Well, we'll talk about the countermeasures, which start with a good antivirus, because they do a pretty good job. But of course they fail, or, they stop where we have 0-day Trojans. So just one small technique: if the Trojan really intends to open some kind of a communication channel that lets the hacker control your computer, then one technique is to see what connection are established between your computer and some foreign host. And of course, from your knowledge of your computer and what's running on it, you might say, hey, wait a minute, this is an unusual, a weird port. It shouldn't be open. I need to investigate it further. So when we talk about this communication channel between your computer, let's say the hacker's computer, of course, this is something that violates your security rules and policies on your computer and your organizational network. So therefore, we call it a covert channel. Okay, covert means hidden, but also violating your security policy. Covert as opposed to overt, which is open, okay, meaning it's legitimate. Yes, I do have currently an overt channel because, let's say, my Dropbox service is running on my computer. So there's a connection established between my computer and the Dropbox server. Other types of malware include spyware. From the word itself, it's pretty obvious. It's a kind of malware that is used to collect information about us, spy on us. And of course, the annoying adware, which is very common. I've seen a lot of my students install toolbars on web browser and install software like BitTorrents and things like that. And you can be rest assured most of these would probably have at least adware, meaning some ads start to pop up. They're unwanted, or of course they use system resources, so we don't like them. One common way, probably a few years ago, it was very popular, is the use of keyloggers as a way to spy on people. Again, when we did the malware lab, we hacked the computer by sending it the malware, and after that it was a rat, so we created a reverse TCP connection back to our computer, to our Kali, and then we used a payload, the keylogger payload. So basically what we did, we were able to capture what the victim was typing on their computer, okay? And now keylogger in general, they can be hardware or software. In this instance, it was software. But for instance, there were a few news articles that I read back in the days where internet cafes would put hardware-based keyloggers, something in the back of their desktops, and when somebody comes and uses their computers, they end up, revealing everything they do because it's being recorded by these keyloggers. So let's move on to classify the viruses. And we will, like I mentioned before, we can classify them or categorize them in several ways. Here is a slide from EC Council, and basically it's two ways of classification here. How do viruses or malware infect us, and what do they do? Oops, let me go back. And what do they do on our computers? So if you take a look at the highlighted ones here, for example, a cavity virus basically overwrites the content of a file. So this is how they do it. But what does a virus do? For example, a file virus, this guy right here, infects a file, right? So if you have files on your computer, it doesn't matter what type of file, it targets files. A cluster virus targets a cluster on our disk drive, okay? It can be the boot sector virus, which means it targets a specific place on our disk drive, which is the boot sector, and so on. So we have really different way of classifying viruses or malware. But in this slide, we're saying what do they infect on our computer, okay? And how do they do it? So let's see some examples here. The macro virus, what does it infect? Well, it infects files and documents that have macro capabilities. Macro is basically a programming capability in some files because they're advanced. They allow us to do advanced things. They're scripting capabilities. So in Microsoft Office, for example, Word, Excel, etc., it allows macro programming using Visual Basic for Applications, or VBA. So with these kind of files, we are allowing scripting, and therefore a macro virus might be a risk. A cavity virus I just mentioned. A sparse infector virus, basically it's a virus. It doesn't matter what it does, so it can be a macro virus, right? A sparse infector virus, it's a virus that does its thing occasionally. That means not every time you open it or you click it or you run it, right? So a macro virus that is also a sparse infector virus in this case would be something in your Word document, for example. You open it 3, 4, 5, 10 times, nothing happens, but you open it on a certain date, let's say June 10th, and then something bad happens. One use of a sparse infector virus is to be undetected, because if you've been using that file for a few months, then the victim is less likely to suspect it as the culprit, right? So it would suspect, he or she would suspect that something recently has happened on their computer. A recent file, a recent website they visited would be what's causing the problem. And of course, there are more advanced types of malware, like ransomware. For example, it infects our computers, our files by, one way is by locking them, encrypting them, and then the word ransom in Arabic, fidya, basically means that you have to pay some money in order for the hacker to give you the key to decrypt. And it's common that they will accept cryptocurrency, in this case, Bitcoins. The other one, rootkit. The word root comes from the Linux or Unix system, where we have the super user root, meaning this kind of malware have a very low level access to your system, a root access. So the name comes from there. And of course, the purpose of having this level of access is to be able to do things almost invisibly, because you can manipulate, change, delete logs, and therefore it will be very difficult for somebody to detect the presence of this malware. And the third one, the backdoor, I might have mentioned it before a couple of times. Basically, this type of malware allows the hacker to bypass authentication. Usually it's done either through a malware or through a recent hack, for example, where the hacker would leave something in your system, allowing them to re-enter it without any effort. How do we evade antivirus software, which is the main security control and protection and countermeasure against viruses? Well, there are different techniques that the hackers would use, including manipulating or changing the way that the virus looks in front of these antiviruses. So one technique the antivirus would use is to look at the signature or the behavior of a file, right? So then the evasion measure of the hacker is to change that signature or that behavior using techniques like encoding and code obfuscation, encryption, compression, and so on. Again, we've seen these evasion techniques in the malware lab. If you remember, we did some encoding and we tried to encode a virus 3 times, 4 times, 10 times, and we saw the different results using virus total. So go back to that lesson or that lab and see what I'm talking about in case you forgot it. Our countermeasure to evasion as security people is to perform proper malware analysis. And there are a couple of techniques in malware analysis that I will mention shortly. Let me just remind you about encoding. Please don't confuse encoding with encryption. They might seem for some of you that they are the same, but they're absolutely not the same. So when we say we encode something, what does it mean? Looking at it, if you have a word like hello or a space in, let's say, an address, a URL address, and then you take it and you convert it into something else, okay? At a first glance, it looks like you encrypted it. No, you didn't. So encryption's goal is security, and encryption needs a key to encrypt and decrypt. Encoding, no, it's just using an encoding algorithm like base64, for example, to convert data from one form to another. And we use it for standardization sometimes. So in case you want to ensure that, let's say, your users are not entering some weird characters into your registration form, what you do is you take their data, you encode it first, and then you send it to your back end. One example I just mentioned is base64. So it's a binary to text encoding scheme. And like I mentioned, it is not encryption. So again, reminder, encryption's goal is security. Encoding is just standard conversion of something. What is the life cycle of a virus? Logically, you can really guess most of these, not guess because I mentioned logically, it would be deduce, come up with these stages on your own. However, you need to know that there are 6 stages. So let's talk about a new virus being created. Number 1, the design phase is when the hacker develops the virus. Number 2 is the replication phase, when the virus or the malware gets spread. So it can be put on a website, for example, it can be sent in an email. Number 3 is when the virus does its thing. When it launches, it's when somebody clicks it and runs it. Remember, this is the payload now doing its thing. Doing what, for example? Deleting your file, overwriting the content of your file. This is what happens in the launch phase. Now, after number 3, we talk about the stages involved, okay, getting rid of the virus. So number 4 would be detection. So we need to know that there is a virus and it's a new threat. This is now a 0-day. So number 5, we need to find a solution for it. Incorporation is about developing a solution. And number 6 is elimination. Please remember that, because I notice what some students always forget: incorporation, right? Why? Because this is a 0-day virus. We're assuming that the virus hasn't been known to the world before. Therefore, there is no solution for it. So we must develop a solution. I mentioned malware analysis. Malware analysis is a technique that we use in security to study and know more about malware in order to do the incorporation and the elimination, right? So the way that we do that, for example, if you're an antivirus company, definitely that's your core business actually. You would be running malware analysis on any new type of virus. And basically what you can do static analysis or dynamic analysis. Static is basically the process of analyzing the code of your virus or your malware, looking at the code, looking at the binary, what is happening over there. In static analysis, we do not run the virus, we don't execute it. So in a way, it is kind of safe, right? Because you're just looking at the binaries and you're looking at things like what's hidden there, file names, hashes, strings. So when the antivirus then is running on your computer and a new file comes in, it looks for these things. It looks for these things that were analyzed during static analysis, and it says, oh, I know this hash. It is part of this kind of virus. So it will do something. It will notify you or quarantine that file. Dynamic analysis, on the other hand, is the process of executing the malware. Okay, so we run it. And of course, you must run this in a very controlled, isolated environment called a sandbox. And otherwise, you would be analyzing the virus, but the virus would be analyzing you, or, you know, harming you. So of course, it goes without saying that we need to protect ourselves when we're doing the dynamic analysis. It is a deeper analysis than static, because we really see exactly what the virus is doing and how it's doing it. This would allow us to reverse engineer it and find the solution for it. So if we would say which one does a better job of analyzing the virus, they're both useful. We need them both, but the dynamic goes deeper. So countermeasures, I would say 3 groups of countermeasures. Number 1, start with us people, with awareness, with education. Don't click, don't download, don't open, etc. And of course, number 2 is to use some kind of technological safeguards. And of course, you can have antivirus, you can have firewalls, intrusion detection, you can perform malware analysis. All of these are technological safeguard. But number 3, we also need to be able to respond very quickly. Okay, so yes, we try to prevent, but in case we don't prevent, what happens when we get a virus? We must be able to respond. So this is incident response procedure or plan kicks in. So in the beginning, I mentioned computer attacks versus network attacks. Let's see some examples of network attacks here. We have 4 examples. DOS, distributed DDoS is distributed. DOS is basically just without the D. Excuse me, it's early in the morning. So denial of service versus distributed denial of service. Okay, so when we say denial of service, basically is an attack on the service's availability. So let's say it's a website, you can attack the server so that the website becomes slower or completely inaccessible. So when we say low impact, meaning just it's a little slower than the usual, this affects the quality of the service, but it becomes critical when we have total loss of availability. Usually, critical is achieved through distributed denial of service, meaning the attack is happening from multiple places, coordinated attacks by multiple hackers, or a single hacker is using a number of zombie computers that they controlled through, let's say, Trojans, rats, okay? And now they have something called a botnet, and they're sitting on their command center, controlling all these computers and sending all these attacks to a single server that becomes very slow, or it freezes because of this attack. Another network attack is to hijack or to steal the session between a client and a server. And the steps here that you see in front of you, it starts with sniffing. Remember, we have a chapter on sniffing. So you sniff the traffic, you try to predict the sequence number. Remember, in my previous file, part 1, I said that we have the transport layer, which has 2 protocols, TCP and UDP. TCP header has something called a sequence number, and I did mention it can be manipulated and used for security breaches. So if the hacker can guess or predict the sequence number of the next packet, what they do, they desynchronize this communication between the client, let's say from one side, and the server from the other, and then they become the server to the client and the client to the server. So basically they can do a man-in-the-middle attack using session hijacking. Ping of death. A ping basically is something that I mentioned earlier. You simply use it at the internet layer using the ping utility. You send very simple packets to troubleshoot a network connection. We can do it, loop back to our computer. We can do it with the gateway. We can do it with another host, right? So when you ping another host, you're sending an echo request and we get back an echo reply. What kind of data are we sending? The ping packet is a very simple packet. Now the ping of death takes this packet and make it a little bit bigger, more than the allowed number of bytes in an ICMP or a ping packet. Then what happens, it's as if the recipient, the target, chokes on that packet because it's big. Then we call it the ping of death. And the way that a hacker would do that is to create large ICMP packets, okay? To bypass intrusion detection and all of that, they can fragment it, and then the fragmented parts, they are reassembled at the destination, causing it to choke or freeze. And finally, a lot of programmers make mistakes, right? So they have bugs in their code. One particular problem in coding in certain programming language is when the programmer don't check for the boundaries of their memory. So basically what happened, let's say you have a cup of water and you're filling it with water, but you're not looking. When it reaches the boundary, what happened to the water? It spills over, right? So a buffer overflow attack targets the vulnerability in poorly written code, and basically even a non-hacker may do accidentally buffer overflow by entering something too big for that field. But of course, what hackers do, they intentionally write their own script that will spill over to the memory or certain areas in the target, creating things like privilege escalation, for instance. Okay, so of course the countermeasures for buffer overflow attack is to write good code. Remember, the security is something you need to include in the design, in the thinking of any system, not at the end. You don't just go there, okay, I created a system, let me now secure it. So remember the security SDLC or the SEC SDLC. SDLC is the system or software development lifecycle. Okay, let's continue with the next chapter, a reconnaissance chapter. Reconnaissance means information gathering. Just a reminder about our phases. So information gathering followed by vulnerability detection, then a penetration attempt, then we report on it, and at the end we do cleanup. So reconnaissance, sometimes it's called footprinting, and we do it either actively, direct interaction with the target, or passively, meaning no direct interaction, it doesn't trace back to us. Sometimes we perform reconnaissance in a legal way. So for example, companies, they perform something called competitive intelligence, where they gather publicly available information in a very legal way to know what the competitors are doing. This is legal. It becomes very illegal as soon as you go into private data and you start doing things you shouldn't be doing. I already mentioned that, so I'm gonna skip it. Footprinting is reconnaissance, is information gathering. So it's a specific technique, okay? So if reconnaissance is a phase, footprinting is a technique where we use to collect information about the target. Any piece of information is useful. Sometimes students tell me, what do I need a name for? Well, this is exactly why. A name can be used to enumerate usernames or emails, and then you can perform different types of attack, including password enumeration attack. You can brute force password now that you have a username. Similarly, a simple website address, you can get an IP address, you can perform web server footprinting, and then you can perform a denial of service attack. So any and all information is useful. Remember, if we have a black box model, we definitely need reconnaissance. If we have a white box model, we do not need reconnaissance because the information is already given. There are different techniques for footprinting. Of course, this is not everything, but these are some techniques, and let's see them in action. Who is? Usually when you have a website, when your target has a website, you can get a lot of passive information about the target using a who is directory. When somebody has a website, they went through a registration process where they registered a domain name, and then all the information they provided during registration is available in a directory online called a who is directory. So we can look up very useful information. And again, I did some demos on tools that you use for who is reconnaissance, including Maltego and Spiderfoot. A simple internet search can sometimes get you a lot of useful information, but of course, we don't do a simple, really simple. We have to use the advanced features of search engine like Google Dorking, for example. Again, I talked about it in some of the demos. You need to know the advanced feature. For example, you can target a specific website or a specific domain and try to look for documents within there. We did an activity in class about that, if you recall. And of course, you can do footprinting on people, including people's directory available online. Most things can be done online when it comes to reconnaissance, but of course, Kali has a lot of tools, around 54 tools available for information gathering. I think, okay. When we talk about websites, again, we can get additional information about the website, including what web server is running and what tools, what technology is being used on that website. The website can be both a target, and it can be itself, it can be a hacker tool. That means if you go to their website, they might be able to get information about you. So information reconnaissance through a, let's call it a malicious website. Important concepts we discussed. Web cookie is basically a file that the web server would use to identify certain things about you. So again, if a hacker has a website, they can use cookies. The good thing about cookies is that we can block them if we want, and there are some tracking cookies. So if you have a good internet protection software, it might tell you when you visit a website, hey, this website has a tracking cookie. Do you want to enable it or you want to disable it? So it's very helpful. Similar but not quite the same, I can use a web bug to get some information about you, to know whether you exist or not. So the idea of a web bug is very simple. Let's say there is you're viewing a website and the website has pictures, okay? These pictures, because you can see them, they are on your computer. But before you visited the website, these pictures were not on your computer. They were on the web server. So simply by looking at the picture, you downloaded it. When you downloaded it, meaning you sent a request, your browser sent a request on your behalf, hey, I would like to see that picture on your web page. And the web server will send you the picture. So a web bug can be used in that sense to invoke a request from the victim, and that request would go to the server, and the server would say, oh, interesting, that email address, that email spam that I sent to 10,000 people, these 1,000 out of the 10,000, they downloaded my bug, meaning they exist. And I put a unique code in each bug, and then I would know which email address is really an actual email address. I mentioned getting the pictures. So basically, web communication is based on the HTTP protocol, the Hypertext Transfer Protocol, either clear text or secure HTTPS. And basically, HTTP is a very simple request response communication model. I want this web page, here you go. And of course, it uses certain methods. One particular method is very popular because we use it almost every time we see a web page, we click a link, is the get method. So get simply gets you a resource. Most of the time, it's a web page or a picture on a web page and so on. The head is the header, so it's for header data. Post, imagine you're registering or you're logging in, so there's a form and you're filling data. Most of the time, I would say above 90% of the time, the data that you're typing in the form gets sent in the body of the message. That means it's not in the URL. And we use the post method for that. Similar to post, but not with data, with files, is the put method. So you put resources, let's say a picture. Delete is the opposite of put. You delete resources. So let's say you have a profile somewhere and you have some content, including pictures, etc. You can use the delete method to delete them from there. They are basically, they can be dangerous methods. So again, depending on what the website is doing. And we have the connect method, establishes a tunnel to the server. We have the options. It actually tells you which one of these methods is allowed. And of course, you have the trace method, which is basically to test, loop back against a certain target resource. When hackers perform phishing and farming attack, they want to create a website that looks exactly like, let's say, a bank's website, okay? Because they want to trick you. They can create a web page or a couple of web pages that look exactly like the bank's website, but they can do it in a much easier way using a technique called web mirroring. So if you use a tool like HTTrack, basically the tool allows you to download a certain website, of course the client-side resources of a website, to your computer, and basically you can then upload it to your own website and use it to trick people. DNS is, I would say, is the most important and technical part of this chapter. So DNS is the domain name system, and it has an inverted tree kind of structure where we have a root, and then you have a top level domain, or TLD. We call it also the parent domain. This is what we see at the end of a domain name. So for example, google.com, hct.ac.ae. So this is .gov, .com, .net, .org. They're called top-level domain. The second level is the child domain. So this is what you actually buy or lease. This is the name that you choose. So google.com, my website.ae, and so on. And then of course you have the third level. These are the hosts and resources. The default one almost always is www. So www.google.com. You don't need to define it or specify it if you already have it available. So I can do google.com in my web browser or www.google.com. They both do the same thing. So when it's different, only then you need to specify it. So for example, sales.google.com, marketing.company.com, then you need to specify it. So let's go back to footprinting. Now that we understand what DNS is, a hacker can get a lot of information about your domain, right? So to do that, they perform footprinting. DNS footprinting, it's also called DNS lookup. And basically, it's a database available for on the net, let's say if it's a website, to be able to find the website. So we have records available for us to look up. These records are called the DNS records. These are the records. You need to know them. Yes, you need to memorize them. And yes, you need to know what each one does. So let me go very quickly over them. SOA is the start of authority. MX is the mail exchange server. So using a tool like Dig, for example, or host or NSLOOKUP, you can specify these records as an option to look up that piece of information. So if I want to know what mail servers are available for this domain, then you use the MX option. NS is for name server. A is the IP address of the host. PTR lists the host domain name identified by the IP address. SRV is the service location. HInfo is the host information, including technical information like the operating system and CPU. Any generic text is usually kept in a special record called TXT. And CNAME is the canonical name, which is kind of like an alias for the server. And finally, RP is the responsible person. Other than these 10 records, we also have a special record that allows you to replicate them all, to get them all. This is called the AXFR record. So I will mention it in the next slide, I think. What are the security risks of DNS? Two things. Either you get everything. This is called a zone transfer, and we will use the AXFR record for it. Or you can actually attack the DNS service itself. So you can perform denial of service attack, and you can do man-in-the-middle attack as well on the server. So let's take a look at zone transfer. To do a zone transfer, you need a special record. Remember the records, NS, MX, etc. There's a special record called AXFR. Using this record, I will do two steps. Number one, I would get the name server of my target. Here, my target domain is google.com. We can assume that this is the result I get, ns1.google.com. Step two, you use this result, ns1, the name server, with the original target with the AXFR. So two steps to perform zone transfers. And of course, we can do additional footprinting on the network, but I will focus on network in the scanning chapter. What are the countermeasures for footprinting? Remember, footprinting is information gathering. So the main thing is always to evaluate the information you're publishing. Is it public? Then no problem. is it private or confidential, then please don't publish it and hide it, because using things like Google Dorking or advanced Google search, you can really discover hidden things. Configure your routers, firewalls, intrusion detection and prevention system to block certain footprinting queries. If it's about website, restrict spidering and crawling. These are the little tools that search engine use to find these places on your website, even if they're hidden. Of course, educate people. It's about DNS, prevent DNS zone transfer, and do what we call split DNS, meaning internal versus external information. You can show the people externally your public information, but it shouldn't identify your internal information. Okay, I will stop for this part. In part 3, I will continue with scanning.